Hi, welcome to the HTP YouTube channel. My name is Peter, and this is the newest addition to the HTP lineup, the Mig 2000i. Input voltage is 240 volts, output up to 200 amps. Simplicity is king. One dial for wire speed, one dial for voltage. For accuracy, you have a digital readout up here. This machine takes 8-inch spools. You can run 023, 30, 35 diameter. You can weld steel, stainless, aluminum. There's a very good door chart on the side here showing you values for material thickness from 24 gauge all the way up to 1/4 inch, wire feed rates and voltages, how much gas you need, what gas flow rate you need, what polarity you need to run. So let's dive into it. We have loaded 030 wire, 030 drive roll. We set the pressure on here. We have attached a Binzel style 15 series gun. We also have connected 75-25 gas and set our flow rate according to the chart. Now, standard 50 amp plug. We're planning to weld 20 gauge material thickness, 15 volts, 130 inches per minute with 030 wire, 135 inches per minute, and 15 volts. And let's see how that works out for us. So we picked some premium material here for you, which is not quite 14 gauge, it's more on the 16 gauge side, but we have this ginormous heatsink under it that we're welding on, at least for this joint. This one here is a little bit off the table, but not much. And of course, these premium coupons, they reflect a real life scenario with a little bit of rust on it, just like you would have at home. And of course, we're making all the mistakes you would make at home. We're grounded to the table, not to the part. So let's see what we got. The weld looks reasonably nice. You see the heat affected zone, the bluing. When you look on the back side, you see there was full penetration. So I would call this a success. Now we have this 1/8 inch metal, still using 030 wire, 75-25 gas. 1/8 inch metal, 320 inches per minute, 18 volts. (320 inches per minute, 18 volts. Now this weld here, this butt joint, no prep, this could have profited from either cutting the chamfer on it or gapping, spacing the material a little bit. It looks a little bit tall and crowned, but you do see some areas got full penetration, others did not. Bluing nice and even. So for all intended purposes, this could be a good weld. You would try to not do a single-sided weld like this. You weld the other side, and at that point the root meets. Or if you have to weld from one side, you have to either have a slight gap or you have to have a little bit like a chamfer, like a V-prep in your joint, so you're not relying on. This is some 3/16 and this is 1/4 inch. And now we're going to try to find a happy spot for this. All these numbers here are designed for a straight line push or pull situation. It's not really designed for any gun manipulation. Gun manipulation adds heat. So what we can do is we can take the 3/16 setting, do a little bit gun manipulation, or take the 1/4 inch setting and focus on the thicker material. But since our joint is going to look like this, the thinner material is on the bottom, I'm going to opt for some gun manipulation. We're going to go to 550 inches per minute, 22.5 volts. So right here I'm doing gun manipulation, and as you can tell, I'm favoring the 3/16 part a good portion more and longer. The 1/4 inch part on the top I'm favoring more and longer than the bottom. So at the end I have a nice weld in there, not too convex, not too concave. And I favored the 1/4 inch part more to get better penetration with the lower setting.